Hi, I'm Matt McCormick from the Department of Philosophy, California State University, Sacramento, and this is my online course lecture on correlations. So first question we're going to ask is, what's a correlation? And this is a somewhat technical idea, technical definition, but here's the idea. When a correlation is present in a population, there are two properties that are connected, such that if a member of that population has one property, then it's more likely for positive correlations to have the other property. Or if it's a negative correlation, if a member of the population has one property, then it's less likely to have the other. And here's the idea. You got a population, you got humans, you got trees, you got squirrels, whatever. And we identify or find some property in that population. So among Americans, there's a rate of them that have diabetes, for instance. And I don't know what that rate is. It's some percentage. And for diabetes to be correlated with something just means that for the people with diabetes, this other property, so suppose it's, who knows, I bet it's high-fat diets. To say that the two properties are correlated is to say that if one property, say diabetes, is present in one of the members of that population, then the other property, high-fat diet, is more likely to be present in that population too, that person. So when you compare the rates of the people with diabetes and the people without diabetes, and then you look at high-fat diets in those two groups, the diabetes people are more likely to have a high-fat diet. So it just says that these rates are higher for positive correlations or lower for negative correlations. So a really good classic example of a negative correlation is education and religiousness. So when you look at Americans, if they have a high degree of education, if they've got a bachelor's degree, a master's degree, or a PhD, they're less likely to be religious. That population has lower rates of religiousness than populations without education. So it's just to say, it's a very minimal claim, it's just to say that these two properties seem to be related somehow, that when one goes up, the other one goes up, or that when one goes up, the other one goes down. That's a positive and negative correlation. That's the idea behind it. Now I want to give you lots of examples and talk about lots of the ins and outs, lots of the details here to work out what all this means. All right, so negative correlations, if a member of the population has one property, then it's less likely to have the other. All right, so we're going to look at positive and negative correlations. So a really easy one, a high-fat diet is positively correlated with heart disease among humans. That is, all of the things being equal, people with a high-fat diet will have higher rates of heart disease than people with low-fat diets. Now, I'm not saying anything about cause. I'm not saying that high-fat diets cause heart disease, although they do. This is just to say that when we take people and we figure out whether or not they have high-fat diets, we can also we can predict that those people with high-fat diets are going to have higher rates of heart disease. Now, it doesn't mean that it doesn't mean most of them have heart disease. It may actually be a very low number overall. It just means that you compare the high-fat diet people with the non-high-fat diet people, and the heart disease rate amongst the first group is higher. That's it. That's all we're saying. Other familiar ones, exercising regularly is negatively correlated with obesity among humans. That's just to say, consider humans and divide them into the ones that exercise regularly and the ones who don't. The rate of obesity is lower among the exercisers than the non-exercisers. And this is sort of an obvious point, you know this. But it's just to say that as exercise rates go up, obesity rates go down for a negative correlation, whereas positive correlations, they both go up at the same time. Okay, so the formal way to state one of these sentences, and the way we're going to use it in this course, is to say that property A is positively or negatively correlated with property B among population P. All right, so we have A, B, and P to keep track of, and then this order. So in this sentence, the one above, property A is exercising regularly, and property B is having obesity, and the population is humans. All right, more of them. Ones you know about, here's a kind of interesting one. So not surprisingly, IQ is positively correlated with GPA, and what's missing here is the population, but among humans. So for people with a high IQ, they also have high GPAs. Those typically go together. Now, that's not to say that everybody with a high IQ has a high GPA. because certainly there's some examples, some cases of people with very high IQs, but very low GPAs. That happens because they can't be bothered to do schoolwork or to actually work on their projects at school or what have you. But the rate of high GPA is higher amongst the high IQ people. Now, the interesting one, though, is also that self-discipline is positively correlated with GPA, too. That is to say, if we measure self-discipline in a population of humans, we find out that their GPAs, the high self-discipline people, have high GPAs as well. And what's really interesting is that the correlation for self-discipline is stronger. And that's what this graph shows. The blue line is self-discipline. That is to say, if you have self-discipline, the odds of you getting a high GPA are better than if you have high IQ. It's a stronger, more substantial, more robust correlation between those two. Now, I'll let you work out the details on how to plan accordingly, how to work accordingly, but there's a couple of positive correlations that help us understand what's going on. Now, one of the big issues here is figuring out the causal issues, but I'll give you some more examples just to get clear on talking about the rates being higher. So here's another obvious one. Swimming is positively correlated with drowning among humans. That is, divide the humans into swimmers and non-swimmers. So take a snapshot of all Americans today, for instance. And today, there's going to be a percentage of all Americans who go out and swim. And you're going to be in one or the other of those two groups, the swimmers or non-swimmers. Now, the ones who go swim, not surprisingly, are going to have a higher drowning rate. And you might say, well, who else is going to drown? That's fine. I mean, maybe it's only the swimmers that drown, but there's other ways to drown. Somebody might drown. They might slip and fall in the tub, or have some other sort of weird accident where they're not swimming but they drown. But the point is that if we split swimmers and non-swimmers into those two groups and we look at the drowning rates, the swimmers have a higher drowning rate. And that's not to say that most swimmers drown. So correlation claims, positive claims, correlations are not asserting that most A's are B's. And I want to be very emphatic about this. It's not to say that some number greater than 50% of swimmers drown. That's not true. It's the same for smoking and cancer and whatever other properties we're talking about. What a correlation just says is the rates are higher. Most swimmers don't drown. The vast majority of people who go swimming don't drown. But some of them do, and that's a higher rate than the non-swimmers. But the percentage of them that drown is higher than the percentage of the non-swimmers who drown. The claim also does not mean that people don't drown in other circumstances. There are people who drown in bathtubs and hot tubs too. So suppose somebody said swimming is positively correlated with drowning among humans, and then somebody offers an objection or a rejoinder. They say, oh well, my aunt had a stroke, fell in the bathtub, banged her head, and then slipped under the water in the tub and drowned in the tub. So that must not be right, that swimming is positively correlated with drowning. Well, look, the claim doesn't say that every single person who drowns must have been swimming. It just says among swimmers, the drowning rate is higher. Not to say that there can't be some other ways that people drown. Obviously, they do. Now, I'm going to say this thing several times. I'm going to repeat it in several ways and talk about it at great length. And you'll hear this over and over again because there's a mistake lurking here that people make so often. And that's that correlation does not imply causation. And I want to tease those out and separate those. We're going to talk about causation next week in the next lecture. But right now, we got to understand that a correlation claim is minimal. It does not make a causal claim. So here's an example. Correlation claims are minimal. It only asserts that two properties are related in some way, but we can't assume that one causes the other or that the second causes the first or make any assumptions about what's causing the thing to happen. So for instance, in this graphic, it turns out that ice cream consumption is correlated with crime. But it's not that crime causes ice cream consumption or ice cream consumption causes crime. And I'm actually going to pause for a second and just think about that. What? Wait, what'd you say? That is, when ice cream consumption goes up, so does crime. So let's split up the world in terms of time. Think about months. So if we have ice cream consumption rates per month, so there's a certain percentage of people or a certain amount of ice cream that gets consumed in the United States in January, and there's a certain amount of ice cream that gets consumed in August. And now I bet you're going to see what's going on here. So the rate of ice cream consumption goes up in August, but it goes down in January. Okay, so it's hot in August and everybody's eating ice cream. Well, it turns out that for whatever set of complicated reasons, crime also goes up when it gets hot. People are inside, they're cold, they're staying in the house. Criminals don't want to go out and get chilled. Or it's too snowy and rainy and icy out, so I don't really feel like going out and robbing that house. So even criminals want to stay home sometimes. So I'm not sure about the full sociological explanation of it, but it looks like when you look at the data, crime rates go up in the summer, and so does ice cream consumption. And it's probably the heat that's causing that. But ice cream consumption doesn't cause crime, and crime doesn't cause ice cream consumption. But the two of them do go up, the rates go up per time. Okay, so the point here, we cannot assume that one causes the other. In this case, it might be a third cause that brings about the correlation. Only that the rates are higher. That's all that a correlation claim says. And the cause of the correlation is the next question for investigation. But a mere correlation, the presence of an association or relationship between two properties, that doesn't imply causation, and that needs to be remembered. You will listen to lots of stories on the radio, on the news, lots of science reporting, lots of news reports, where sometimes the reporter or sometimes the person who's working on presenting the story makes this distinction and keeps them separate, but sometimes they don't. Okay, so some more correlations to consider. Let's see, school children have a higher chance of having asthma if their school is near a hazardous waste site. Now, there's the claim. Here's the claim put into standard form for a correlation. Asthma is positively correlated with going to school near hazardous waste sites among children. All right, so that's rearranged and inverted and put into that standard form where property A is positively correlated with property B among P. So I've arranged it and put it in this format. And once you get used to doing that, you can see and understand what's going on here, that we can see what the properties are. And the idea here is if you take school children, for instance, let's take all American school children. And right now we could divide those up into the ones who are going to school near hazardous waste and the ones who aren't. So let's define near hazardous waste sites as, say, within 20 miles. All right, so you could take those populations and separate them out. So there's some school kids who are near a waste dump and some kids who aren't. And if you check those kids for asthma, you will discover that their asthma rates are higher than the other group. That's all we're saying. The asthma rates are still pretty small. It's a minority of kids who have it. But if there's a hazardous waste site nearby, their asthma rates will be higher. Now, again, we don't know what the cause is. It might be something completely different. You would have jumped to the assumption that it's the waste, it's the garbage, it's the hazardous waste site itself that's causing the asthma. Certainly this looks awful and gross, this picture, and you'd assume that that wouldn't be good for kids' lungs. But hey, there might be something else going on there. Let's not prejudge the issue. Let's not be hasty. Remember, one of the things we're trying to do is to learn how to train our frontal lobe to consider, slowly and carefully consider the facts and ponder the possibilities. Here's a possibility you might not have thought of. It might be that kids in poverty are more likely to go to a school that's in a bad geographical region that's got a hazardous waste site or a dump nearby, you know, because the poor kids have got poor housing and poor neighborhoods, and poor neighborhoods are more likely to have dumps in them or hazardous waste sites in them. And that poverty itself leads to higher rates of asthma because those kids are, their families also smoke or they're exposed to other risk factors. So it might not be that the hazardous waste itself is causing the asthma, it might be something else altogether. So you've got to be able to reserve judgment and consider these alternatives before we jump to the causal conclusion. But the only thing we're claiming here is that the rates are connected. Here's another one. Babies born to affluent families tend to have higher birth weights. That's to say, put into standard form, higher birth weight is positively correlated with being affluent among babies. And affluence means rich or wealthy or economically well off. So if you take babies and you split them into the rich babies and the poor babies, or for that matter, the fat babies and the skinny babies, you will find that this other property jumps out, that it's higher. That is to say, the percentage of affluent babies, because babies have lots of money, right? Well, the kids from rich families. The percentage of affluent babies with high birth weights, and we can define high birth weight however you like. In a study that would have researched this, they would have looked at it and said, okay, anything over 7 pounds 12 ounces is a high birth weight, or anything over 8 pounds or 9 pounds or whatever. It doesn't matter for our purposes. The percentage of affluent babies with a higher birth weight is greater than the percentage of non-affluent babies who have a high birth weight. For any particular baby, the odds of its having a high birth weight are higher if he or she is from an affluent family than if that baby is not from an affluent family. All right, so that brings out some more of the details, or the sort of the idea for what's behind this notion of correlations. Now, here's another one. People with public sanitation systems live longer than people without, and there's a pretty direct causal connection here. But I'm just saying, here's the point. If we look at, say, people in some third world country who don't have a public sanitation system, their lives are typically shorter than people who do have a public sanitation system. And this is pretty direct. It just contributes straight to health. That if you don't have a good public sanitation system, you have problems with garbage and with contamination, with cholera and typhoid and disease rates and all that, and those go up, and that pushes longevity down. So the correlation put in standard form here is longevity is positively correlated with public sanitation among people. Okay, more. Being in the NBA is positively correlated with having big shoes among humans. And I put this in there specifically to illustrate this point that correlations are not always causal. And this one says a weird thing. You might wonder, why is this important? Well, it's not important, but it's kind of interesting and kind of entertaining. It just says that when you look at NBA players versus non-NBA players, and then you check to see who's got big shoes, the NBA players have a higher rate of big shoe possession than the non-NBA players. And this is sort of obvious, right? Because these guys are so tall, and they're really tall, and they have big feet. And Shaquille O'Neal wears like a size 24. I saw one of these, a Shaq shoe in a shoe store once, and it's like, I can't get it on the camera. The thing was like 24 inches long, right? Look at that shoe down there. Just to say that if we split humans into NBA and non-NBA humans, and presumably everybody watching this video is a non-NBA human, so you guys compared to NBA people, and then we check to see what percentage of those two groups have big shoes, that percentage will be higher for the NBA guys. Okay, here's one interesting. Owning a cat may increase the chance of suicide. It turns out that cat ownership is positively correlated with suicide among women. All right, so this is real data. It's a fact, and this cat's happy about it. That's what he's trying to do to you. No, but for real, when we compare women, take women. I think this was done for American women. You split them into cat-owning women and non-cat-owning women, and then you look at the suicide rates in those two groups. The women who own cats have a higher suicide rate. Now, again, it's not that causation, that correlation implies causation. And some people are actually going to get defensive about this and sort of start defending their cats or the cat ownership. Or, I've got a cat and I don't feel suicidal. That's fine. That might be right. Although somebody might be out there and got a cat and they're feeling down and go, oh, maybe that's it, I gotta get rid of the cat. No, don't make the assumption about causation. There's something else perhaps going on here. For whatever reason, cat ownership rates among women are connected up to suicide rates. That the two of them, that when one's high, the other one's high as well. The suicide rate is higher among women who own cats than among women who do not. So you may know a crazy cat person, somebody who's got, well, I have a theory about being a crazy cat person. At what point does cat ownership become crazy cat ownership? And my theory is that it's 4 plus n. So any number greater than 4 cats and you're into the territory of being a crazy cat person. Now, I don't know whether that puts you in the suicide territory too. It probably doesn't. But what we found when we do the research on this, and somebody actually went out and measured it, I suppose. Maybe it didn't cost very much. What we've looked at is that some folks are prone to have cats, and for whatever other reason, there's a higher suicide rate there. But again, correlation does not imply causation. And here's another one that illustrates this point really well. Having a car wreck is positively correlated with using your windshield wipers among drivers. And this one's weird. What? Okay, so what does that say? Well, compare the people in a car wreck with those who aren't in a car wreck. So today, for instance, in America, there are 300 plus a million Americans. A whole bunch of those are going to drive. So take driving Americans today, and a whole bunch of them are going to have wrecks. A minority of them, but some of them are going to have wrecks. So now compare the car wreck Americans today with the non-car wreck Americans today, and then look to see who is using their windshield wipers. And the car wreck people are going to be using their windshield wipers at a higher rate. That's it. That's all we're saying. And I'm deliberately using this one to force us to acknowledge that correlation does not imply causation, because this is really bizarre, right? It's just saying that car wreck people are more likely to have been using their windshield wipers. And in a second here, you'll see, if you haven't already, what's going on. The first group has a higher rate of car wrecks. So that's to say, people in a car wreck today compared to people who are not in a car wreck today, if we measure to see what percentage of the first group are using the windshield wipers versus what percentage of the second group are using the windshield wipers, we would find that X is greater than Y. Now, why is that? Compare the people using their windshield wipers today with people who aren't. The first group was more likely to have been not using their windshield wipers, but to have been in a wreck. That's to say that correlations are symmetrical. These two claims are equivalent. The idea here is, and partly what I'm trying to get at is, that rain is the third cause. When it rains, that causes two things. It causes car wrecks. Not everybody has a car wreck, but a higher percentage of people who are driving in the rain have wrecks. And rain also leads to people using their windshield wipers. So this is like that when the temperature goes up, ice cream consumption and crime go up. When it rains, windshield wiper use goes up and car wreck rates go up. So it turns out then that windshield wiper use and car wrecks are correlated. And these two sentences, the next point I'm trying to make here is that they're symmetrical. Correlation statements can be flipped and they mean the same thing. Both of these are true. They mean exactly the same thing. Windshield wiper use is positively correlated with car wrecks, and car wrecks are positively correlated with windshield wiper use among drivers. Okay, more. People at the doctor's office are sick at a much higher rate than others. This is why hopefully you wash your hands. Does going to the doctor's office cause you to get sick? Sometimes it does. Sometimes you get a staph infection from being at the hospital. Does being sick cause you to go to the doctor's office? Certainly. Most or many of the people who go to the doctor's office are there because they're sick. So the sickness led them to go to the doctor's office. So that turns out to be causal. But we're just talking about the correlation right now. Are there some non-sick people at the doctor's office? Yeah, maybe you drove your friend, or maybe your dad drove you to the doctor's office and he's not sick, but you are. So not everybody there is sick. But here's one of the important points we want to tease out. If A is positively correlated with B, then what might be going on here? What might be the result? What might be happening? Well, it might be that A causes B, it might be that B causes A, or it might be that some third cause C is causing A and B. All right, so we're going to leave open the conclusion about what's happening or what's making this thing, these two factors being correlated. And another thing that happens is that sometimes correlations are accidental. Sometimes they're just completely off the wall. They're very remotely, distantly related, but it turns out there's a connection. And this one's going to blow your mind. Here's a bizarre one. The number of people who drown by falling into a swimming pool, it turns out, is correlated with the number of films Nicolas Cage appeared in. Nicolas Cage movies are positively correlated with people drowning in swimming pools, and there's the data. Now, it's not that Nicolas Cage is causing this. It just turns out this is one of these weird sort of strange things that's happening out there in the United States or in the world that's a result of some, who knows, some economic phenomena. Who knows what's going on there. Okay, here's some, I'm going to give you some more, just rattle off some more correlations to sort of tease out what's going on here. It turns out that people who smoke pot are more likely to try heroin. People with a college degree are less likely to be religious. White Americans are more likely to be Republican. Black Americans are more likely to be Democrat. New gun buyers are 57 times more likely to commit suicide. Now, that's not to say that buying a new gun makes you commit suicide, but the two are correlated. So that if we look at new gun buyers versus non-new gun buyers, the suicide rate is higher in the first group. And here's another one that got reported on the news. Women who buy guns are much more likely to be murdered. Now, I actually heard this one on the news, and I heard a news reporter confuse this and make it sound like this was causal. And this is a mistake. But the news reporter described this as if women, you shouldn't be going out there and buying guns because that will lead to you being murdered or cause or imply that you'll get murdered. And that doesn't seem to be the facts at all. There could be something else going on here. It might be that women go out and buy a gun because she's being threatened or menaced, or she's afraid of an estranged boyfriend or husband or whatever. So it's not the gun buying that leads to her getting murdered. It's some other dangerous circumstances that leads her to go buy a gun and then also leads to her getting murdered. Another strange, random, accidental correlation in the world. The main divorce rate is positively correlated with margarine consumption. What the hell? Why are those two connected? Don't know, but correlations are accidental and they're puzzling and bizarre. And here's another one that will surprise you. And I don't want to imply or suggest that there's a causal link here, but it turns out that autism rates and organic food sales have been going up together. Very strong correlation here that autism diagnoses are positively correlated with organic food sales among Americans. What the hell? Is one causing the other? I certainly don't want to suggest, I don't know what's happening here, I don't want to suggest that organic food is causing autism or that autism is causing organic food consumption. That's probably not what's going on. These are two separate sociological or cultural trends that probably don't have anything directly to do with each other, but it turns out that they both happen to be going up. That's to say that correlation does not imply causation. And here's another one that's connected up to the one we talked about earlier. Look at the data here. Ice cream consumption and drowning are correlated. So if you look at May, June, July, and August, the deaths by drowning go up 20, 25, 30, and the ice cream sales go up 150, 200, 250, and I don't know what this particular data was here that they were looking at. So as ice cream consumption goes up, so does drowning. But that doesn't mean you should avoid ice cream consumption, or that there's some sort of connection there. It just turns out, again, it's probably the heat that's leading to both. Okay, so if A is positively correlated with B, then there could be several things going on here. It might be that A causes B. It might be that B causes A. It could be that there's some third cause that causes them both, or there might be some accidental connection. In this case, it's a third cause. Ice cream sales are positively correlated with drowning among humans, and the third cause is summer temperatures. Okay, so let's summarize the whole thing. You've seen a number of really subtle and important concepts and details and principles about how correlations work. Correlations are, here's what they are. Two properties are correlated when their rates in a population are associated. That's all we're saying about them. A is positively or negatively correlated with B among P is the standard form of a correlation sentence as we're going to use it in our discussions. If an individual in the population A has A. Okay, so we've got some population and we pluck out some individual who has A. They have diabetes, or they're eating ice cream, or they're using their windshield wipers, or they have big shoes. Then that individual is more or less, if it's a negative correlation, more or less likely to have B than the other individuals who don't have diabetes, or they're not using the windshield wipers, or they don't have big shoes or whatever. We've learned that correlations are symmetrical, that when you flip them around and turn them over and reverse the two factors A and B, they mean the same thing and they're equivalent. And we've also learned, and I've tried to be very emphatic about this, very clear, that correlations are not all causal. Correlation does not imply causation. To discover a correlation is just the first step in uncovering causation. But we can't assume, if we find these two properties that are associated, that one causes the other, or make an assumption about which one causes which. I mean, you might have some common sense here, but we've learned that we've got to be cautious and reflect on this and puzzle over the causes. Okay, so that's going to be our next project, is to have some discussions, and in my next lecture will be about how do we figure out when something's causing something else in the world. And it turns out that at a minimum, one of the necessary conditions for A causing B is that A is correlated with B, but there has to be a lot more we have to discover and argue for or uncover in the world before we can reliably infer that there is a causal connection. So correlation is a necessary condition of causation, but it's not a sufficient condition of causation. And I'll let you go back and refer to necessary and sufficient conditions from one of our earlier discussions to think about what that means, and I'll bring it up some more in the next causation lecture. All right, so that's our discussion of correlation.